We are back again. We are going to try and hit set 4 today. We're going to do Network Plus, set 4 for the questions. 5 new multiple choice questions for your Network Plus exam. Obviously practice exam questions for you to go through and hopefully learn something from. Hopefully you get a better idea of how you're doing in your Network Plus studies. That's our goal for today. We are trying to provide you with an explanation of the questions more than just the questions. So this is how this works if you haven't done this before. We're going to jump in and we're going to read a question. We'll give you a little bit of time to figure it out. And then we're going to break down the question and we're going to find out why the answer is the answer. Because remember, when you get the certification, it's not enough just to get that piece of paper. Getting the piece of paper, yeah, it's great. It's awesome. You've accomplished something. You've got that recommendation or that gratification to knowing that, hey, I earned this, right? But more importantly, it will be easier to not only answer those questions, but to answer interview questions if you know why an answer is an answer. You can go through and cram. I see students do it all the time, and you could probably pass your exam. But how it happens 10 minutes, 20 minutes, 2 days after your exam's done, you still have to retain that knowledge. And if you don't, well, then you're going to be in a world of hurt, and why did you bother to get the certification in the first place? So we really want to do the answers and not do exam dumps. Don't do question dumps, but really kind of understand why the answer is the answer and be able to pick through it. And if you can do that, if you can critically think, you'll do very well on these exams. So without further ado, because I know you didn't come here to hear me just talk about whatever, let's jump into set 4 with question number 1. What command is used to display active network connections and listening ports on a Linux machine? What do you think? What command is used to display active network connections and listening ports on a Linux machine? Yeah, this one's a little bit difficult because Network Plus almost requires you to have an understanding of not only the Windows system, but a Linux system as well. While some commands are interchangeable between them, you have to pay attention to what the question is asking. It's asking specifically on a Linux machine. Now, this is something that CompTIA does quite often is, does it matter that it's on a Linux machine versus a Windows machine? Sometimes it does, sometimes it doesn't. So make sure that you're paying attention. This is where knowing the different operating systems, knowing the machines for networking perspective really kind of comes in handy, all right? All right, let's go ahead and answer this question. If I didn't give you enough time, you go ahead and pause this video. Remember, we only want to spend about 30 to 45 seconds on each question and then move on with our lives. Any more than that, and we're spending too much time, we're not going to have time to give our performance-based questions the time they need. And so 30 to 45 seconds is what we're trying to shoot for. We also want to be able to review questions after we're done. If you do 30 to 45 seconds per question, you should be able to accomplish everything you need and then still have about 10 to 20 minutes left over at the end of the exam to go over everything if you so choose. That's our goal. All right, let's answer this. What command is used to display active network connections on listening ports on a Linux machine? Well, ifconfig will give us the internet protocol configuration. It'll tell us everything about it. It'll give us MAC addresses. It'll tell us that loopback address. It'll even tell us our current IP address of what we're operating on currently. But it will not give us current network connections. That is not something it will do. Traceroute. Well, let's drop down to C. Let's drop down to IP address. It does the same thing, pretty much. I honestly feel like it does the same thing, but it doesn't really. It gives us our current IP addresses associated with our Linux box, right? IR more often than used. I use ifconfig more than I use IP ADR, IP address. They do pretty much the same thing. Yeah. And then that leaves traceroute and netstat. Now, traceroute is, if you watched the video from last week, then you know that traceroute goes through and it hits every router on the way to its destination, but it doesn't give us active ports or connections. That's going to be network statistics, or a netstat is going to be our right answer. I place this at the easy range based on the answers provided. I feel like it would be a harder question if the answers were more closely related, but they're not. In this case, it's going to be netstat. Netstat is going to be our correct answer, and there you have it. All right, moving on. Question number 2. Which layer of the OSI model is responsible for establishing, managing, and terminating connections between applications? I know I know. You're probably going through your mind right now. Please do not eat sausage pizza, right? Is it? No, wait. Please do not throw away sausage pizza. My bad, right? You're probably going through that and you're like, okay, wait a second. I was prepared for this. I was prepared to figure out what layer 4, 5, 6, and 7 were, but I wasn't prepared for actually having to know the OSI model. Yeah, you have to actually know the OSI model. That is part of what we do. I also want to point out that they changed the TCP IP model recently back to 5 layers, which makes it easier in some cases, more difficult in others. If you're used to the 4 layers of the TCP IP model where they combine layer 1 and 2, that is no longer a thing. Layers 5, 6, and 7, 5, 6, and 7 are still combined into the application layer, but 1 is now separated from 2, and it does the same thing. Physical to physical, so on and so forth, all the way up the line. All right, let's answer this one. If you're not ready, go ahead and hit that pause button, but let's answer this one. Which layer of the OSI model is responsible for establishing, managing, and terminating connections between applications? It's a lot easier than you think. We know it's not the physical layer, right? We know that it's not raw bits. We know that it's not a physical characteristic of the data. It's not raw data. Therefore, it cannot be the physical layer. I feel like that was an easy one to mark off. However, that leaves data, transport, and session. And I feel like there's tricks to learn this if you're not familiar. Remember, if I want to establish, manage, or terminate a session, then I would go through the session layer. That's right. It would be session layer. Remember, establishing, managing, and terminating sessions. That's how I remember it, believe it or not, is that we are doing that with a session. And so it was kind of easy if you know that trick. Transport layer doesn't really do that. Data link definitely doesn't do that. When we talk about the session layer, it establishes connections. It manages those connections. And when you're done, it says goodbye to those connections. That is the session layer, 100%. That's going to be our correct answer. Start using this in your lingo when you start talking. If you're brand new to networking, I'm establishing a session. I'm going to create a session. I'm going to manage my session. I'm going to terminate my session, right? Not connection, session. If you do that, trust me, that is the surefire way to remember that the session layer is responsible for doing all 3 of those things. Not much more of a trick, but a great trick to remember if you're going through it. Ooh, I like these types of questions. What does the following output from the ifconfig command indicate? I cannot talk today. What does the following output from the ifconfig command indicate? I'm going to screw this up all night. I'm going to give you a few seconds to read through this. There's a lot of data here, but what is it telling us? What is it telling us on this command feature? A lot of information to run through. What are we looking at here? All right, if you need an extra minute or two, I'm going to let you pause it. I know there's a lot of data in here to read, something that we would expect to see. I would rate this as a very hard question on your Network Plus, just because of how much data is here. And you have to read it. You have to be able to read it. So let's actually read it. Let's read it first, right? So, because I know it's not in order, we are on Ethernet 0, ETH 0. That's Ethernet 0. We have our flags, 4163. Our connection is up. Our broadcast is up. We're running multicast with MTU of 1500. Our internet address, our INET, is 192.168.1.100. So that's our IP address. Our subnet mask is 255.255.255.0, meaning that we are operating on a /24 network, because right there, that's 0. Our broadcast address is 192.168.168.1.255, which is a little bit weird. Not really. It's on 255. Not really weird, right? And then our INET 6, this would be our IPv6 address, is right there, which I'm not going to read. Our scope, we have a link, and we can see ether 00, and we have a MAC address. And then it's telling us that TX equivalent 1000 Ethernet, meaning that is usually our Ethernet connector. And we've received 12345 bytes of 1234567 bytes, or 1.2 megabytes total. And we've transmitted 6789 bytes, or 789 kilobytes if you run through that. All right, so that's how we read that if you have not seen this before. So let's dissect this one, right? The internet, or the interface, is down. Well, it's not down. We know it's not down because right here at the very top, our flag says up. And so our internet connection is very much up, right? So definitely, or I should say our system is up. Our network card is up. Our interface is up. We can see that here. I cannot talk today, right? And so ETH0, which is our Ethernet connection 0, is actively up. It's working. It's not down. Let's drop down to the bottom over here. The internet interface is promiscuous mode. It is not in promiscuous mode. There's nothing in here stating it's in promiscuous mode. We can see that it's broadcast, running, and multicast, not promiscuous. So that is not the case. The interface has no IP address assigned. Well, it 100% has an IP address assigned. It is 192.168.1.100. It's right there. And so that can't be right. So B, the interface is up, which it is, and has an IPv4 address assigned, which it does. So that means our answer is B. I hope that was educational. I hope that was educational. I know we ran through that pretty quick. If you need to, you can always rewind it or rewatch it again and see where I went through with that. But the interface is definitely up, and it definitely has an IPv4 address, so it is operating normally, and we can see that there. So our answer is going to be B. All right, next question. Given the following output from the ping command, what can be inferred? What can be inferred from this ping command? Another good situation to be able to read that we need to be able to get from this. What do you think? What do you think? We saw a similar question last week. Is it the same or is it different? What do you think? All right, let's tackle this one. Given the following output from the ping command, what can be inferred? Let's read it first, shall we? We are pinging google.com, right? We're pinging Google. It gives us the IP address, 172.168.1.4.238, and we sent 56 of 84 bytes of data. We got 64 bytes from the IP address, which is google.com. We see it's ICMP sequence number 1. The time to live is 1:15, and the time is 20.2 milliseconds. We can see sequence number 2, same basic thing, with a 20 millisecond. And then sequence number 3, time to live 1:15, with 19.8 milliseconds. All within a pretty good line. So we're not saying too much in here, but what does it all mean? Does it mean the destination is unreachable? Well, absolutely not. The destination is reachable. We're receiving ICMPs back from it. We're receiving a response back from google.com. And since we are, it is obviously reachable. Next one, let's drop down to D. The DNS server is not resolving the hostname. Well, the DNS server is resolving the hostname. It's right here on line number 1. We pinged google.com, and the DNS server came back, and it said google.com's IP address is 172.277.14.238. So it did resolve, the DNS server did resolve the hostname. That leaves B and C. C being there's packet loss occurring. Well, do you see packet loss occurring? If we saw packet loss occurring, we would see sequence 1, and then we'd see something missing, and then maybe sequence 3, and then maybe sequence 5 because it missed sequence 4. And that would provide us where we had no response from the server. We're not seeing that. So that means the network connection is stable with low latency. And again, just a different way from reading it from last week. A little bit more information, but the answer is still the same. So if you watched last week's video, we have another example of that. If not, well, you probably know now that answer. So there we have it. The answer is going to be the network connection is stable with low latency, which is pretty obvious, right? But I hope you learned something from that. There you go. There you go. All right, next question. Which protocol is used for secure file transfer over a network? I feel like this one is probably easy. I wouldn't say very easy, but I would say easy. Okay, what do you think about this one? I'm gonna give you a few seconds to answer this one. I don't feel like you need a lot of time for this one. This is where another point of you must know the acronyms. If you know the acronyms in Network Plus, Security Plus, CYSA, or any CompTIA exam, I honestly believe the acronyms make up 40% of the exam. Just by knowing the acronyms, I feel like you're guaranteed to get 40% on the exam. Now, that's not a passing grade, but it will help you. It will help you. All right. If you need more time, go ahead and pause that video. Remember not to look these up. Don't look them up. Take a guess if you don't know, okay? Remember, we learn from our failures, not from our successes. Which protocol is used for secure file transfer over a network? Well, file transfer protocol, A. Well, that's definitely file transfer protocol, and it definitely moves files over a protocol, but it's not secure. FTP is definitely not secure. Then we have TFTP, definitely not secure. And then we have HTTP, again, not secure. The secure version would be HTTPS. That must mean that C, Secure File Transfer Protocol, is our correct answer. I feel like this one was a gimme. Remember, when you're looking at protocols, 90% of the time, not all the time, 90% of the time, S means secure. There are some exceptions out there, but S usually stands for secure. In this case, it follows that same rule. So we are operating on Secure File Transfer Protocol. C is going to be our correct answer. All right, that's it for tonight. That was our 5 questions. I hope you found this to be educational. I hope that you learned something from it. If you did, I would really appreciate that like, that subscribe, and of course that bell icon to be pressed right there. Smash that sucker down for me. My name is Dr. K. We will see you next time. I appreciate you. Thank you so much. Have a good night.